Hello everyone. Today we will deal with the concept of free fall. What do you mean by free fall, children? Free fall is a fall of an object under the effect of gravity only and no other forces. Before going to the details of this free fall, let us just remember about an experiment done by Galileo Galilei. He put a feather and a coin from the Leaning Tower of Pisa, and he observed which one will reach the ground first. So obviously we know that and we expect that the feather will come down, right? And this experiment was again improvised by Newton, where Newton used a feather and a coin inside an evacuated cylinder. So he put this feather and coin inside the cylinder and he evacuated it and he just turned it upside down. To his astonishment, it was seen that the feather and the coin reached the other end of the cylinder almost simultaneously. What is the difference between the two experiments, children? We have to look for it. In the previous case, it was gravity acting on the feather and the coin, and there was air resistance also. Some external force like air resistance was acting on it. But in the case of Newton's experiment, there is no air resistance, only gravity is acting inside the cylinder. So, keeping in mind these two examples, we have to go for the concept of free fall. So, what do you mean by free fall? Free fall is a fall of any object under the effect of gravity only. And those bodies in free fall, they are having an acceleration, and that acceleration is called acceleration due to gravity. So somebody may ask you, what is the difference between acceleration that you have studied in the first chapter and acceleration due to gravity? So acceleration due to gravity is the acceleration of a body under free fall, and you can write that, and free fall is a fall where only Earth's gravity is present and we do not consider any other forces of nature like air resistance, wind, etc. Now let us study what are the factors on which this acceleration due to gravity on Earth or any other planet depends on. And to remember, what will be the unit of acceleration due to gravity, children? The unit of acceleration due to gravity is the unit of acceleration itself. What is it? Just remember, it is meter per second square. So now we are going to derive a relation where what are the factors on which this acceleration due to gravity depends on. So just try it. So consider that Earth is there and Earth is having a mass m, and a body is on the surface of the Earth. It has been falling down and it just reached the surface of the Earth. Let the body is having a mass m, and from the center of the Earth and till where the body is placed, let the distance be r. Okay, so in order to derive the acceleration due to gravity, the first step that we have to apply is according to Newton's law. According to Newton's law, what is Newton's law? Newton's second law, here we are specifying. According to Newton's second law, what is the force of the body on the body by the Earth? So what will be that? And we know that it is F is equal to ma. So here when the body is falling down and just touching the Earth, what is the acceleration due to gravity? We have already studied this acceleration due to gravity is small g, right? So according to Newton's second law, we know F is equal to m into a, isn't it? So here F is equal to m into a. A here is the acceleration due to gravity. So we can say that it is m into g. Let this be our first equation. So what is the next concept that we are writing the same force between the Earth and the body according to Newton's law of gravitation. So, what is according to Newton's law of gravitation? Tell me, children. According to Newton's law of gravitation, I have just abbreviated it. What is a force according to Newton's law of gravitation? It is capital G into mass of the earth into mass of the body divided by r square. Isn't it? Because it is the distance between the center of the earth and the mass. So, we know that in the left side, it is the same force acting, right? It is the force on the body by earth. So, if this force is the same, can we equate the right hand sides? So, equating the right hand sides, we will get mg is equal to g into m by r square. Here you get that this m and m are the same. That is the mass of the body. When we cut it, what will this equation be like? G is equal to capital G into m by r square. Closely look at this equation, children. We have derived the acceleration due to gravity on the surface of the earth G. It depends upon the universal gravitation constant. It depends upon the mass of the earth. It depends upon the radius of the. Now you have to tell me, what are the factors on which an acceleration due to gravity on a planet depends on? If we have considered that this is Earth, if it was some other planet, the mass will be the mass of the planet. So, tell me, what are the factors on which the acceleration due to gravity depends on? It depends upon the mass. Here it is the mass of the earth, or we can say that it is mass of the planet, where we are concerned about the acceleration due to gravity, and it is the radius of the earth or radius of planet. So, we are recapping it once again. What are the factors on which acceleration due to gravity on a planet depends on? It depends on the mass of the planet and radius of the planet. Greater the radius of the planet, lesser will be the acceleration due to gravity. So, once again, it is G is equal to Gm by r square, isn't it? So, my question to you, is this acceleration due to gravity depending on the mass of the body? Where is the mass of the body in this relation? So, we can conclude that the acceleration due to gravity on a planet is independent of the mass of the body dropped. So, now remember about the Newton's experiment. When there is no other force and there is gravity only, the feather and the coin will reach the other end of the cylinder simultaneously. At the same time they will reach, because this acceleration due to gravity is independent of whether the feather is having any mass or stone is more massive, like that. So, we can just think about a question. A 2 kilogram body and a 10 kilogram body are under free fall. Which will reach the ground first? So, what is your answer? Both will reach the ground simultaneously. Hope that you have understood how this acceleration due to gravity depends on the parameters of the planet. See you in the next class.